Hello everyone. Today we'll discuss the second portion or second class of binomial theorem. Already in the last class we have discussed the expansion of binomial theorem, number of terms in a binomial theorem or expansion. Today we'll discuss the general term in a binomial expansion and the middle terms in a binomial expansion. These are the outlines of today class. And consider any binomial expansion or common form a plus b whole to the power n, and using combination notation, also using Pascal triangle, we can use as c n0 or nc0 a to the power n minus 0 b to the power 0 plus c n1 a to the power n minus 1 b to the power 1 plus c n2 a to the power n minus 2 b to the square, and so on of the last term one cnn a to the power n minus 1 b to the power n. Already I told in the last class, this is the general form of the binomial expansion or for positive index. Now consider in this binomial expansion how many terms. Now see, this is first term, this is second term, this one is third term, and the last one clearly it is nothing but a n plus 1th term. I write this one here. Here T1 notation stands for first term. This is say n0, or you can write also this one as nc0 a to the power n minus 0 b to the power 0. Similarly, second term as nc1 a to the power n minus 1 b to the power 1. As the third term nc2 a to the power n minus 2 b square, and so on. Mark here in each term and in your combination notation the number of terms of the one, the suffix of combination is 0, means just one less than. Similarly, second term T2 cn1 or nc1, the suffix of the combination is 1 less than the number of terms. And clearly continuing in this way, what is the last term? Clearly this is the n plus 1th term. This is nothing but n plus 1th term, whose value is what? ncn a to the power n minus n and b to the power n. And clearly already you know ncn is 1, a to the power 0 is 1, and clearly this is now only b to the power n. And continuing in this manner, we can find any term by applying the different values to n. I write here tr plus 1. Any term in the form of rth value taking r different values, we can find the different terms of a binomial expansion. This is the now general term. How we get the general term? This is tr plus 1 is cnr or ncr a to the power n minus r b to the power r, where a is the first term of the binomial expansion and b is the second term. N and r already you know these are positive integers, n always greater than or may be equal to r, and by giving the different values to r we get a different terms or all terms of the expansion, and this one is called general term. Why it is general? We can use to find any term of the expansion by giving different values to r. N is always fixed because the power here in our expansion a plus b to the power n is fixed. R is a number, r may be 0, maybe 1, maybe 2, and so on, maybe 50 and so on. Using this one, suppose I can an example, write the general term in the expansion x plus 2y whole to the power 7, and compared to our statement a plus b whole to the power n. What is a here? In this n here question, a is equal to x, b is nothing but 2y, and n is nothing but 7. Power n is 7. What is now general term? Formula CNR a to the power n minus r b to the power r. So tr plus 1 or the general term is CNR b to the power n minus r b to the power r, which is nothing but c of 7r. n is here 7. What is the a value? A is the first term of the expansion x to the power 7 minus r means n minus r, and 2y whole to the power r. And after simplification, it is clearly c or combination. You can write also 7 cr x to the power 7 minus r and 2y whole to the power r. This is the general term, or after expansion, this is now individually taking power 2 to the power r and y to the power r, whose final answer is c of 7r, 2 to the power r, x to the power 7 minus r and y to the power r. So similarly we can find any expansion, the general term, what is the answer one. Let us another take middle term. In our today discussion, very important one is middle term. Already know, suppose I take there are 5 fingers. How many? Which is the middle one? From left side or from right side? This is the third one, is the middle one. Now see, 5 is an odd number. That means see, when the number of terms is odd, there is only one is the middle. Suppose I take 6 fingers. Similarly, which are the middle one? These two are middle one, which is nothing but a third and a fourth one. So using this fact, that means see, number of terms in a expansion, after expansion, whether it is odd or even, the middle term determined. I write this one again. In the binomial theorem or expansion, a plus b to the power n, already know there are n plus 1 terms. If here n is even, and so that n plus 1 will be odd. If it is odd and this is now n plus 1 is even, suppose 5 is power, number of terms is 6. 6 is clearly even number, 5 is odd number. If n is equal to 6, that means even number, n plus 1 is equal to 7, which is odd number. So depending upon the power in the binomial expansion n, whether even or odd, there are two category or two formulas. I write here, if n is even, then n by 2 plus 1 is the middle term. That means only one is a middle term. That means when the power is even, the number of middle term is only 1. If n is odd, for example 7, 9, 11 and so on, there are two middle terms, and using the formula pattern, this is nothing but n plus 1 by 2 and n plus 3 by 2. Let me see, suppose n is equal to here 7, odd number. So middle term is what? 7 plus 1 by 2 means the fourth term, and the next one is the fifth term. Using this fact, consider an example. First we take one of the general question, how to find the terms, a particular term in a expansion, binomial expansion. Suppose I take binomial expansion here, 3x plus y whole to the power 5. Question is to find the third term. Then we see, in our usual formula, to find the value of t3 and taking the help of a general term tr plus 1, that means here t3 is nothing but 2 plus 1. Clearly r is what here? R is 2 and n in your question means here is 5. So using the formula CNR a to the power n minus r b to the power r, here a is equal to 3x, b is y, that means c5 to 3x whole to the power 5 minus 2 and y to the power 2 or y square, and which is nothing but c52 or 5c2 3x to the power 5 minus 2 y square, and after simplification, and c52 is a combination formula using, we get the value as 10, 3q is 27, 27 10s are 270, x cube y square. So this is all about your find the term of a expansion. Now come to a question, how to find middle term in expansion depending upon the number of terms is odd or even. Find the middle term in the expansion x plus 1 by x whole to the power 9. See, in our question, n is a odd number or 9 is a odd number. Since it is odd number, in the last slide already discussed, when odd number, the number of terms is what after expansion 10. Clearly there are two middle terms, and which are by using a formula here n is equal to 9 odd number, so there are two middle terms which is nothing but n plus 1 by 2, other is a n plus 3 by 2, 9 plus 1 by 2, and second one is 9 plus 3 by 2, which is nothing but fifth term and a sixth term. So that means we have to find here T5 and a T6, and using which one? The general term or general formula to find the term of expansion. Clearly in our question n is equal to here 9. When you require to find the T5, this is nothing but taking the help of a TR plus 1 formula. This is T4 plus 1. Clearly R is equal to 4 here. So using the formula CNR, C94, x to the power, x is what? X is the first term, means A is x. Here A is equal to x, B is nothing but 1 by x, and a particular for this one R is equal to 4. And using in their proper places, C94, x to the power 9 minus 4, 1 by x whole to the power 4, and after simplification we will get this is nothing but 126x. So another middle term is T6, means is sixth term, and using the same formula TR plus 1, 5 plus 1, and so on, we get after simplification this is nothing but 126 divided by x. Similarly, we can take other examples, maybe even number. Take the another help of another example. Suppose find the number of terms in the expansion. More questions about our binomial theorem. 1 plus x whole to the power n and 1 minus x whole to the power n. Now see, in our expansion 1 plus x plus to the power n itself is a binomial, multiplied by 1 minus x to the power n, it is another binomial. Don't think its number of term is n plus 1, its number of term is n plus 1, then we see this is nothing but n plus 1 whole square. This is a wrong answer. So what is the answer now? We have to combine these two binomial to a single binomial. Now see, these two terms in a lies under a usual formula. We can write this one as 1 plus x whole into 1 minus x whole to the power n. Clear? Already know a to the power n into b to the power n, which is nothing but ab whole to the power n. And 1 plus x into 1 minus x, this is under again a formula a plus b, a minus b, a square minus b square, which is nothing but 1 minus x square whole to the power n. See, this is now binomial, a single binomial, and in this binomial, as per our previous discussion, the number of terms is just one more or n plus 1 term. So how many terms in the number of in this expansion? There are n plus 1 number of terms. Another example we can consider, find the middle term in the expansion 2x minus 1 by x cube whole to the power 8. Now see, in our question whole to the power 8 means 8 is a even number. So since it is even, there are only one middle term. n is equal to here 8, and clearly it is even number. So there is only one middle term. And which one? And using our formula n by 2 plus 1 means 8 by 2 plus 1, which is nothing but a fifth term. That means in this expansion we have to find the value of only T5, and again using the previous knowledge T4 plus 1, and n is equal to here in this question n is equal to 8, R we get now 4, A is equal to 2x, B is nothing but minus 1 by x cube. Minus important, don't write plus here because between two terms given minus sign, B is minus sign. So using the formula NCR means 8C4 x to the power, here A is 2x, 2x whole to the power 8 minus 4, and second one is minus 1 by x cube whole to the power 4. And using our common pattern, 8 into 7 into 6 into 5 divided by 4 factorial means 4, 3, 2, 1, and 2x whole to the power 4, 2 to the power 4, x to the power 4 minus to the power 4 is plus, this is number x to the power 12. After simplification, 4 to 8 cancel here, 3 to the 6, 70, and this is nothing but 2 to the power 4, so 70 into 16 into, this is nothing but x to the power minus 8, and this is our final answer. You can multiply again, right? So this is the middle term in the expansion. Similarly, we can discuss in the last class previous more questions. In the next class, we will discuss about further more about the binomial theorem. So thank you all.